In this video, we're going to start talking about the unit circle. So let's talk about how the unit circle is created. The unit circle has an equation that is like our most basic form of a circle. It's x squared plus y squared equals 1. So we just finished talking about circles. Notice this one has a center at the origin, so at 0, 0, and a radius that's equal to 1. So it's the most basic circle, and it's a very important little circle because it helps us to derive the graph of cosine and sine. So we're going to talk mostly in this video about how the unit circle is created. So let's review for just a minute special right triangles. So we have two types of special right triangles. There's a 45, 45, 90 triangle where we have two legs that are equal length. So I'm going to write that over here. This is one leg and this is one leg. And then the hypotenuse is considered to be the leg times the square root of 2. And then we also have a 30, 60, 90 triangle. That's another type of special right triangle. And it has one side that's considered like your short leg is what we could call that one. So the short leg, we call that one just X. The hypotenuse is always 2 times the short leg. So I'm just going to write twice the short leg. And then the long leg is always the short leg times the square root of 3. Sorry about that. So the unit circle, we mostly focus on the first quadrant and everything else can come from there. So what I have in this next page of my notes is the first quadrant of the unit circle over here to the right. And then I have broken it out into the 3 major angles we start with. So if you notice, if I move this little red triangle over to the unit circle, it creates a right triangle that has a vertex at the origin. It has a hypotenuse of 1. It would have a short leg, which is equal to, so let's refer back up here. So if my hypotenuse is equal to 1, that's twice the short leg. So the short leg would have to be 1/2, and then the long leg is 1/2 times the square root of 3. So let's just fill that into our triangle down here. So we have the hypotenuse is 1, the short leg would be 1/2, and the long leg would be the square root of 3 over 2. So what that means is we have a point on our unit circle at 30 degrees, and the point would correspond with this special right triangle that we could create whenever we need to. And we have the horizontal length of the square root of 3 over 2. So that's our cosine. Cosine is always the horizontal measurement. And then 1/2 is the vertical distance to get to that point on the unit circle. So notice I had to go to the right a square root of 3 over 2, and I had to go up 1/2, which makes me have the coordinate of that point. So I'm going to scoot this red one out of the way for just a minute, and we'll bring it back in a little bit. So I'm going to move it over there. Let's focus on the blue one now. So the blue one is the one that goes in the middle. This is the one that creates our 45-degree coordinate. So we have a point on the unit circle that's located at 45 degrees, and we want to know what the cosine value and sine value for this theta, this central angle, would be. So we refer back to our special right triangles again. This is a 45, 45, 90 triangle, and we know that the hypotenuse is equal to 1. Because if you notice, the 1 is always our radius of our unit circle. So then we could say that if that's equal to 1, so I'm going to move this x square root 2. So we know our radius is equal to 1, and that's the hypotenuse, but we need to solve for x. So I'm going to say x square root 2 equals 1, and then if I solve for x, I have to divide by the square root of 2, and so x would equal 1 over the square root of 2. But in math, we don't like to leave radicals in the denominator, so we rationalize the denominator. by multiplying it on the top and the bottom by what would make the denominator come out evenly. In other words, we have a square root of 4 now at the bottom of our fraction because the square root of 2 times the square root of 2 is the square root of 4. At the top, we have 1 times the square root of 2, and we would just leave that as the square root of 2. So then that just gives us the square root of 2 over 2. So we figured out that our legs are equal to the square root of 2 over 2, and they are equal to each other. So let's put that in our unit circle. So we have a cosine value of the square root of 2 over 2. That's how far we have to go to the right. The sine is the same thing for this one because they're equal. So I had to go right square root of 2 over 2 and up square root of 2 over 2 to get to the point where 45 degrees is located on the unit circle. Now I'm going to scoot that one out of the way, and we'll work on the third angle that we need to create the entire unit circle. Very exciting. So this one is actually just the opposite of the red triangle that we've already worked on, because now our theta is 60 degrees and it was 30 degrees for the red one. So we're locating the 60-degree coordinate on the unit circle. If you notice the short leg, well, let's say our radius is still 1. We know our short leg would be 1/2 because that corresponds with the one over here that we've already worked on. So we don't have to think about that again. We know it's equal to 1/2. And then we know the long leg is equal to the square root of 3 over 2. So cosine is always the horizontal distance, which is 1/2 in this case. And then sine would be the vertical distance. So that's the square root of 3 over 2. Okay. So let's move all of these back into place now. And it's going to look a little messy for sure. But something really cool happens now. Once you have figured out those 3 coordinates, you can figure out every single coordinate in the entire unit circle. So, very exciting stuff. Let's take a look for just a minute at the whole circle. So let's start with the basic points. So our basic points are this very first point. Remember, the radius is equal to just 1. So that would just be 1, 0. And that's located at 0 degrees right now. And at the end, it'll also equal 360, but we'll get there in a minute. So if we go to our first quarter of our unit circle, that would be located at 90 degrees. And the coordinate right there, notice we went up 1 because the radius is still equal to 1 for this unit circle. So our coordinates are 0, 1. Let's go 90 degrees more. So this is 180 degrees now. Notice the radius is still equal to 1, but now we went to the left 1. So we went -1, 0 to get to 180 degrees. And then we can fill in the third major quadrant, or like quarter of our unit circle, which is 270 degrees. And then we went down 1, so we would have gone neither left or right, but down 1. Okay, so those are the major 4 points. Let me just add in that 0 is also equal to 360 degrees. All right, so let's bring in the ones that we were working on. So we have the 30 degrees is the coordinate square root of 3 over 2 and 1/2. So cosine is square root of 3 over 2, sine is 1/2. Then we have, I'm going to put the degree measure. So we have 45 degrees is located at the coordinate square root of 2 over 2 for our cosine and square root of 2 over 2 for the sine value. And then our 60 degree angle has a coordinate at 1/2 square root of 3 over 2. Okay. Now what is super cool about these 3 angles is if you know those 3 and you can get the basics filled in, you really can fill in the entire unit circle from here. So a big thing to remember is that the first quadrant is positive, positive. The second quadrant, so remember this is the second quadrant, first quadrant. So first, second, third, and fourth. Remember it forms like the letter C. So your first quadrant is always positive for sine, positive for cosine and positive for sine. So cosine's positive and sine's positive. Your x, in other words, for each coordinate is positive, and your y is also positive. For the second quadrant, it'll be negative, positive. The third is negative, negative, and the fourth is positive, negative. So what happens is these 3 points that we figured out and took a lot of time with up here in our first quadrant are the same around the circle. They just change sign. So notice this 30-degree angle would also be right here. And we just need to change the signs so that those are appropriate. And we can figure out the degrees in just a minute. So we would have negative square root of 3 over 2, positive 1/2. All right. The one in the middle is always the blue one. So that would be negative square root of 2, positive square root of 2 over 2, because we're just changing what quadrant it's located in. And the green one would be the one closest to the other green one. And that would be negative 1/2, positive square root of 3 over 2. For the degrees, you just have to take 90 degrees and add 30. So we have 120. Take 90 degrees and add 45 degrees. So you have the blue one would be located at 135 degrees. And then take 90 degrees and add 60 degrees, and you get 150 degrees. So the degree measures are to take those 4 major sections like 90, 180, 270, and add 30, then add 45, and then add 60. And that's an easy way to calculate the degrees. So for this next quadrant, I'm going to start doing the same thing. So 180 plus 30 is 210 degrees. And my coordinates are going to match. I'm just going to change the sign. So they're the same ones I've been writing in red all along. But now they're both negative. So it's negative square root of 3 over 2, negative 1/2. The blue is in the middle. So take 180 plus 45 and you get 225. The coordinates are the same. They're both just negative now. So I have negative square root of 2 over 2 and another negative square root of 2 over 2. All right, and then the green one means I need to take 180 and add 60. So 180 plus 60 is 240 degrees. And the coordinates of that point would be the same as all of the green ones I've written down. So negative 1/2, but they're just both negative. So negative 1/2, negative square root of 3 over 2. All right, let's continue around. So the green one means I need to continue with the green one next. And I would say 270 degrees plus 30 degrees would give me 300 degrees. Coordinates stay the same. The signs just change. So I have positive 1/2 now and negative square root of 3 over 2. All right, for the one in the middle, I need to take 270 degrees and add 45 degrees. So I get 315 degrees. And the coordinates are the same. The signs just change. So I have square root of 2 over 2 and negative square root of 2 over 2. And the last one I need is the red one. So I take 270 plus 60 would be 330 degrees. And then the coordinates are the same. The signs are different. So I have square root of 3 over 2 and negative 1/2. And now I have all of the degrees and all of the coordinates for my entire unit circle, and they all stem from that first quadrant. So I realize that's a lot of information quickly. So it would help you to most likely re-watch this video and just watch the pattern unfold and not be writing anything down while you're watching. And just get a gist of this unit circle. We're not going to take it much further than this, but we are trying to give you a good introduction of it. So notice the entire unit circle forms from those 3 special right triangles that we looked at in the first quadrant. The signs of your coordinates change, And then your degrees have the pattern going around the circle, that you add 30, you add 45, you add 60. You add 30, you add 45, you add 60 to each of those 4 quadrants. So hopefully this helps give you an introduction of the unit circle. I'm going to make another video to show you how to pick out an exact value of the unit circle.